How are you doing? This is Muhammad, and in this video, we will discuss about how to apply the Six Sigma knowledge in your practical business. I made this video because I received a lot of questions from a lot of people who are interested in taking the knowledge of Six Sigma and apply this knowledge in their work, but they don't know how to apply it. You know, a lot of people, they have the knowledge and they cannot apply, or a lot of other people, they don't have the knowledge. They need to take the knowledge, but from the practical point of view, okay? Not only to take the certificate and they will be happy with the certificate, but no real action on the ground, okay? So in this quick video, I will explain to you on real example how to apply the processes of Six Sigma, okay? Before we start, let me go through a quick academic introduction about the Six Sigma. So I will explain to you how or what is the Six Sigma and what is the content of the Six Sigma, okay? So I know I have here a long course, but I'll try in this short webinar. I'd like to make it very small but intensive webinar to give you the knowledge in the shortcut, okay? So I will jump through the other slides. Okay, this is about me and my experience, okay? Let me move quickly to the Six Sigma cycle. I will explain it to you. What is the Six Sigma cycle? Okay, before we move to the Six Sigma cycle, just I will put the slide and then we will discuss about the definition of the Six Sigma. Yeah, here's the point, okay? What is Six Sigma? Six Sigma is a methodology, depends on the tools and techniques, using statistical tools and techniques to enhance the process or removing the defects from the process, okay? So in the Six Sigma, we depend on collecting data, analyzing this data, and then find the root cause of the defect, or find the root cause which if we attack, we can enhance the process, okay? And then we start setting action plan, and then taking action. This is simply the Six Sigma. So Six Sigma is looking for where is the problem and how can we find solutions for this problem, okay? So what is the difference between Six Sigma and Lean, okay? Both of them are working on enhancing the problem or enhancing the performance of the process or removing the defects, okay? But here is the difference between Six Sigma and Lean. Lean works to remove the or to enhance the process, or to figure out the problem and solve the problem by finding out the variation in the process, finding out the defects in the process, finding out where are the problem and root causes of these process, so that if we remove it or eliminate it, we can achieve profitability or some, you know, customer satisfaction or something like that. The Lean is working on the same result, but working through removing something called waste. And waste here can be time, can be extra inventory, can be extra process, can be very long procedures, you know, like that. So as a summary, Six Sigma works on removing the defects from the process, and I mean by fixing the variable or the difficulties or the defects in the process. And the Lean working by works by removing the waste, okay? And to understand this waste can be time, okay? It's not only time, but I mean to understand, you can just recognize or understand it by removing waste such as extra unnecessary time, okay? Okay, so let's come back to the Six Sigma, and before we jump to the practical implementation on the real example, so let's discuss the processes of the Six Sigma. So in the Six Sigma, we have 5 processes, and these processes we say it's one cycle, this cycle called the MAC cycle. And the MAC cycle we took the first letter of each process and we could, we have this form of, or with this word, the MAC cycle. So the MAC cycle contains of the process number one, define, measure, analyze, improve, and control. Okay, very simple. And very logical, by the way. So I will explain it to you in such a way that you will not forget it. So the first line of the first process in Six Sigma cycle is define, and define simply like that. Do we have a problem? Do you have a problem? Yes or no? Would you like to have a project to solve this problem? Yes or no? You know, like that. So in the define, you just decide that you have a problem, and you decide that you will create a Six Sigma project to solve this problem. This is the define. So in the define, you create something called project charter, and you identify the team, you identify the stakeholder, you create something called problem statement, and you identify the items that are critical to quality, CTQ, which means the customer requirements that related to quality. Okay, so in the define, simply define. If you need to remove the word define, you can just remove define and write set the target. Okay, this is the first process. Second process is measure. And as I said, in the Six Sigma, we depend on data, collecting data, analyzing data, find the root cause of this data, and attacking the problem due to the root cause of this data. So measure is the process of collecting data about the process. In other words, you can say that measure is the process that you find the baseline, the data. Where are you now? Okay. If you need to move from one point to another point, you have to identify where are you now. If you understand where is the first point you are in, you can then decide the target. Okay. So in the simple way, you can remove the word measure and write collect data, just collect data. Okay. And of course, in each process, we use tools and techniques. Okay, maybe in the difference between Six Sigma and the traditional management. In the traditional management, you depend on the data and the leadership, or the personal power, or the leadership to take actions. But here in the Six Sigma, mainly you depend on data, collecting data, and then you work with this data. So the measure, you collect data using different techniques, just as survey, brainstorming, interviews, and then you collect this data in data sheet, histogram, and Pareto, and all of it. Okay. Again, if you need to understand more and more about the academic Six Sigma, you can refer to my channel. You have some video about totally free course for the yellow belt. You can understand this, and you can then take also the international exam in the Six Sigma yellow belt through my website, nasergy.com, to be certified as Six Sigma yellow belt certified. Okay, but here I'm focusing in this video about how to apply. So just I'm giving introduction, and then we will jump to the Excel sheet and we apply. The third process is analyze. And analyze, you take the collected data in the measure process and you start analyzing this data to find the root cause. Okay. As a methodology in the Six Sigma, we don't work with the data like that. Yani, as a raw material, you work with this raw material to reach the root cause, which have the same, or which has the impacts on the process. So you move to analyze and find the root cause and the vital causes. If you have like 10 causes or 10 root causes, what are the main 2 root causes? If you find them, if you attack them, you will have everything fine. Not 100%, but most of the problems will be eliminated. So you can remove analyze and write, find the root cause. Yes, find the root cause. So define, measure, analyze, and then you move to the 4th process. Okay, now you find 1 or 2 root causes which have the main reason of the problem. Fine, let's find solutions. So in the improve, we find the solutions, you set action plan and you take action. This is the improve. So you can remove the improve and you write plan for action or taking action or finding the solutions. All of these are correct in the improve. Okay, and then you move to the last process, which is control. And in the control, you can just say sustain. You set a plan, you achieve results, keep it, repeat it, like that. So this is in simple way the MAC cycle. So in the real projects, we apply the MAC cycle as I said, using the tools and techniques in order to achieve results. Okay, so in the next step, I will start selecting a project and I will go through quickly through these steps to understand how to apply a Six Sigma project in the reality. This is number one, and this is totally free to help you apply the knowledge. Okay. Okay, I will not be happy if you understand something. Okay, of course I will be happy if you understand something, but you need to apply it. You need to put it in the practical implementation. You need to teach it to someone else. Okay, so that you can add real value to the environment. You can add real value to your company. You can add real value to the world. So this is my objective, and I'll start giving you this free implementation, and also I will give you another surprise, which is Excel sheet. The template is totally free. Just contact me through my WhatsApp, through my email, through my website, and then I will deliver, or I will send you this Excel sheet. So let's move. Fine. Moving now to the Six Sigma template. Here we go. In the Six Sigma template, we have here introduction, which contains the main, the data you need to know about the Six Sigma. What are the levels of the Six Sigma? What are the range of each Sigma level? So that you have in your background, you have the reference data. You can use it as a reference. Okay. And then here the define, which you create the charter and the problem statement and the stakeholder. And then the second process, which is measure. And I will tell you the details about the project we will work through. The third process is analyze, improve, and control. Okay. So here we go. We start with the introduction. And in the introduction, we have here the Six Sigma table. So we have the Sigma level, 1 Sigma, 2 Sigma, until 6 Sigma, and you have the defect rate and then the yield. Fine, let's explain to you what is that. Okay, we start the 6 Sigma. We start with the 1 Sigma, and 1 Sigma means that you have in each million items, assume you have 1 million items as production in your factory, okay? For each 1 million product, or for each 1 million items, you have 770 item defected. If you have this number or above, defected items, this number or above, it means that you are working on 1 Sigma level. 1 Sigma level, okay? Fine, you start making some improvement, some enhancement until you reach to less than 770 items defected. That means you are working with the 2 Sigma level, which mean the performance, your items is above 69.1. It means say 69.1 of your items are okay. This is the yield. So you can remove word yield and write performance. You can remove the defect rate and write defected items. You got it? And then, you know, the more Six Sigma level you reach, the less defected, I'm sorry, the more Sigma level, the higher level you need to reach, it means the lower defected items you have, okay? Until you reach to Six Sigma, and Six Sigma means you have defected items means equal to or less 3.4. So if you have 2 items defected from 1 million items, it means you are Six Sigma, okay? And this means that in the Six Sigma, you are working on a performance equal to 99.99966%, okay? Fine. This also explains the range. Yani, it means Six Sigma, it means you are working from 0 defects up to 3.44. And then the more defects mean the lower Sigma level until you reach to 1 Sigma. Fine. Let me quickly move to you to this table. Here it means, and this advanced table, I put it here as reference for you. The yield is a performance defect per million, DBMO, it means defect per million opportunity, which means the defected item per million, the defected item per million produced item or items. And then the Six Sigma level. And here what I need to say, it's fluctuating from Six Sigma until a you know, even less than 1 Sigma. Okay. Here, if I need to say I'm working in the Six Sigma level, it means that I am working with 3.4 defected items, 3.4 defected items per million, which means 99.99966 or 9997. And here we go. You have here, you know, these defected items, it's going slightly above. And the more you go, the more defected items you have, the lower Sigma you have. You got it? So you will use this table, you know, it's like here from 99.9997 until 8%, you know, as a performance. And in each line, you have defective per million and you have Sigma level. Fine. I also received a question here. If you have defected items, assume you are working here, okay? If you have here defected items, 910. So, I mean, defected per million opportunity, 910,000. Here in this table, you don't have 900,000. So how can I use it? I use it in my real project. And this is, now I'm working in practically, okay? If you have defected items between 900 and 920, I created this interpolation table for you. So here you will write the target. What is the real defected items per million you have in your industry? So assume you have 910,000, okay? This is what we have. Then you write here your current DBMO and you write here the upper and lower. Which means, what is the lower defected items here? The above, here from this table, above 910 is 900, yeah? And above 910 is 920. So you are working in between this. So what you will do here, just you write 900,000 and you write here 920,000. And in the same method, you write here, in this 900, what is the Sigma level? So Sigma level is 0.22, yeah? So we'll come here and write 0.22. Okay, and in the same, what is the, if you have DBMO 920, what is the Six Sigma? So from the table, the Sigma, what is the Sigma level? You have this Sigma level, and then you will have here in the defects per million 910, you have Sigma level is 0.16, okay? So I need to say you use this table if you don't have your number, your DBMO clear in this table. Fine? Fine, let's move on. So the next step here is to, let me make sure the video is working or no. Stop sharing, share again, screen. Where is me? Fine, we move to the next the next tab here, and we start with the first process. And the first process here is define. And in the define, you simply write something called problem statement. You write the project charter. You write why you need to have this project. So you write here the project name, the purpose of the project, what is this project, what you need to do in this project, and you can divide it into phases, and you can write the milestones and when you will deliver the milestones of this project. Then you write the voice of the customer, and simply the voice of the customer, you write what is the customer requirements in terms of the quality. Okay, and so on. What I have done here, I just repeated this again, but here you can just remove it simply, and you can write the customer requirements instead of this. And also you may need to collect the stakeholder register and the team who will be working with you, okay? This is the first process. You just write here what you need to do in that project. Let's move to the real implementation, and you start the real implementation from collecting data. Fine, the project is, let's assume we have a project to create this paper cup. And this, we estimate that we have a factory. This factory has 2 production lines. The capacity per hour in each line, 500. The shift hours is 6 hours. Number of shifts, three shifts per day. Number of days, 24. Number of months is 11. You collect this data, and then you have products item per year. You just multiply them, and you have 4.7 million cups per year. Fine, collecting data. Here we will use the check sheet to collect data, and the check sheet is a table or tally that you will collect the number of defects, all the defects that happen to this product. In order to understand this more and apply it more, you need to realize and write down the steps of your production. So for you, of course, you remove this and you write your own. Yeah, this is just an example. And then you will come here to the check sheet and write all the defects that you have. So maybe you have problem in handling the paper reel, you have problem in printing, the die damage, the cutting accuracy, and all of this. And as I said, you depend on collecting data. So you collect the data through the, the year months. So in the year months, you collect what are the database, or what are the logs you have in Jan, Feb, March until December. And again, you need to have a register for your reading, for your measures, so that you can collect data easily. If you don't have, you may depend on the survey, okay? If, depend on the project, but you can collect data by having surveys, brainstorming, interviews with the team to collect this data. So what I need to say here, this is, let's say, a problem of printing machine, heating system. You have these defected cups per each month, okay? Fine. Then after collecting these defects, you need to have total number of defects annually. So I have 441,783 defected cups per year due to that reason, okay? Then the next step is you need to analyze this data by having the Pareto chart and histogram. So you will collect all these data again here, okay? And then you will say number of defects. So what are the total number of defects. So you will just, what you will do, you will collect the total number of defects in this item, okay? So you will collect these items, and this total is coming from all the months. In the accumulative of all months, and then you have it here. So you have the number of all defects, okay? And this is the total, okay? And then this is the percentage of total production. So the 441, what is the percentage of this defected item from all the product you have produced? Okay, so it's 9% defected item per year, okay? Fine, so you have 9% defected item, and then other column, what is the total of each defect in the overall defected items, which means what is the percentage of this defect from the all defected items? Like, for example, I have 14,000 defected item due to paper heel handling. Okay, what is the percentage of these 14,000 from the overall defected items? So it's 3.2. You got it? Why you are doing that? Because, as I said to you, we're collecting data from the measure step, but we will not work on all the collected data because we need to use the most impacted items, or the effect of the most items or the most severe items that cause the most problem, so that we need to attack. Because we don't have a budget, we don't have time, we don't have effort to attack all of these defected items. Fine. So if you look here, you have this defect which has the majority of the defected. So it has 3.1 from the overall production, and it has 33.6% from the defected, overall defected items. Let's apply this on Pareto. So what I need to say, in your project, you will take this Excel sheet and you will just remove this defect and write your own, and the calculations will be calculated automatically. And the sheet also, and the curve also will be calculated automatically. So in this Pareto chart, you have here the majority is the rolling accuracy, okay? And by the way, how to create Pareto, you just will select the data, and then you will write here, insert chart. You will select this bar, and you will find Pareto. Where it is, somewhere here. You just will find it where I got it. I think it's here. Okay, let me, you can find it here. I cannot find it now, but I created here, and Pareto means it will tell you what is the most impact or important factors that has the majority of the defects. You know, Pareto is 80-20, so the 80% are coming from these first items, okay? The first 4 or 5 items. And here is the decision point. You decide how many numbers you need to focus on based on the budget, based on the time. And we decided here in this project that we will focus on one item or one defect, which is the rolling accuracy, which has the majority of our defected items. So we decided here based on the voice of customer, and after meeting with the customer, we decided to start working with this defect to eliminate or to reduce that effect or that defect. Fine. Then we move to the here, you know, as you can see here, number of defected items, which is the rolling accuracy of the machine. And it has 148,654 defected item, which is 3.1, so that the yield here, the performance is 69.9. And based on that here, you will have the defect per million. How can we calculate the defect per million? Very simple. Here, what is the total production? The total production is 4.7 million. Fine. So 4.7 million. From these 4.7 million, you have 148 defected items. So you will do the math, you know, like that. You have here let's say 4.7 here. Let's just write it here, equal 4.7. Okay, and from this 4.7, you have defect items equal to 148. Fine. Then you will say, okay, when I have 4.7 million, I have 148 defected items. So what if I have 1 million? What is the X? And here X equal to, you make the interpolation, you write that multiplied by that over 4.7, you will have this number. Okay, so, sorry, here. So the DPM of, in your case, is 31,282. So this is the defect per million. And what you will do here, you will go to the reference table. Do you remember this table? And you will find the DPMO 31,282 where it is. Okay, so 31. You write here in the interpolation, and then you will take the lower and upper items. So 31.2, it means here, yeah, in between these two numbers. So the lower number is 28 something, and the upper number 35 something, and the related Six Sigma 3.4 and 3.3. So you are something in between. You write those here, and you write also those parts here, and then you will have your current Six Sigma level, your current Sigma level. So your current Sigma level is 3.36. You got it? Please, if you don't understand any point, just contact me through email or YouTube comment or WhatsApp, and I will try to explain it in other way. Then, so your current Sigma level is 3.36. Fine, so what is our target? Here's the point. You will have a meeting with the management, you will have a meeting with the customer, you will have brainstorming session, you will have interviews with the customer to explain and understand from them the target.